Today is Friday, December 12th, and we're going over the partner test from yesterday. This is section 4.4, which is graphing rational functions. Okay, so the first thing we need to see is what is the domain? In other words, what numbers could we, when we go to graph this function, what numbers could we actually put into this problem to do? Well, it's going to be all real numbers except what? Except when the denominator gives us a 0. So if we were to factor the numerator and the denominator, let's do both. So this numerator is x, so you're going to do plus 4 minus 1. There's nothing to cancel. So our domain is all real numbers except x cannot be 5 and x cannot be -2. Why can't I plug a 5 or a -2 into this function? Yeah, because the 0 will be in a denominator and you can't have that. Next, number 2. Now we're going to go into graphing these. These were each worth 11 points. I need to see something on each line. So number one thing you're going to do is what? Factor. The numerator factors to be x minus 3, x plus 1. Denominator x plus 2. The first thing you're going to want to do is see if you can cancel anything out. Canceling something out will give you a possible what? A possible what? Whole. Did we cancel anything? No. Now remember, only if something is removable will you have a whole. Because if you have an overabundance of vertical asymptotes, if you have an extra one, it's not going to create a whole. But in this case, we're not canceling anything, so there's no whole. Next, let's start at the top. What are our critical values? You're going to have a critical value at each of these places. At 3, at -1, and at -2. We're going to use this critical value in a minute when we do our exclusion chart. Our roots are where the numerator is set equal to 0. So at 3, 0, and at -1, 0, our graph is going to cross the x-axis at 3, 0, and -1, 0. Next, our vertical asymptote, that's where the bottom is set equal to 0. Please make sure you're complete. It's a vertical line. The name of the vertical line is x equals -2. I am going to draw this vertical line in red to show you that you are not going to cross. It's a hot spot. Can't cross that line. Now this is top heavy. It's top heavy by 1. So what of these three do we have? We have a slant asymptote. We don't have a horizontal. We don't have a parabolic. Now how can we do this slant asymptote? We can do long synthetic division or long division, but synthetic is the easier of the two. Can you do synthetic division on any problem you want? No. It has to be degree, the denominator has to be degree of 1 and leading coefficient of 1, but this one's good. And how do you perform synthetic division? Bring down the first term, multiply, add. Now, do we need this? No, we don't. We don't even have to finish it. So these two are going to give us our linear slant asymptote. It's a line, and it's top heavy by 1. How do you graph y equals 1x minus 4? Well, everyone should be able to graph a line by now. You're going to begin at -4, 1, 2, 3, 4, and you're going to go up 1 over 1. Now in red, this is an asymptote. It's not part of the graph, so that's why we don't connect the dots. So if you want to make it more of a pronounced broken line, that would be great. What do these vertical and slant and parabolic asymptotes do? They direct your graph. Your graph is getting closer and closer to those lines, but the only one it could cross is a horizontal asymptote. And if you had a horizontal, and if it does cross, it's simply to pick up a root or a y-intercept. How do you find the y-intercept of any any problem, you plug 0 in for x, and you could plug it in. The easiest one to do is the original one. If I zero x here, and x here, what's remaining? Negative 3 halves or negative 1 1/2. This is a solid, rock solid line. How do you do the exclusion chart? Well, your critical values need to go in order. In each of your factors, so x minus 3, x plus 1, x plus 2, and f of x, or y. So, how do we fill out this exclusion chart? What do we do? Well, you're going to locate your 0. At x minus 3, your 0 is right at this spot. One of these 3 will be your 0. To the left will be negative, to the right will be positive. X plus 1, negative 1 is your 0. Negative, positive. And negative 2, negative, positive. And this is where we count. 3 negatives, negative. 2 positive, negative, positive. All I did was count. So now I did this for second hour, and they seem to like this little technique. This tells us that we are from negative infinity, this is negative infinity, to negative 2. We are in the negative region, negative zone. So where is negative infinity to negative 2? It's right here. Here to here, it's saying we are in this zone. So where are we not? We're not in the positive zone. So I'm going to block out this region. I'm going to darken this region just so I can mentally take a look. How can I put myself in this quadrant right here in this region where I'm going to be in the negative region using these two asymptotes. You'd have to be in this region right here. Why am I not drawing something here? Because I'm exposing myself to go up in this region. That's the only way. I don't have an asymptote here. If I did, I would probably draw something in this region. How could I be 100% sure? You could plug numbers into your problem like negative 3, negative 4, and it will help you get to this spot. So if you get in a crunch and you don't know where to go, some of you guys are saying, well, how do you know where to go? Take a second and plug some x values in, and it's going to direct you down here. It will. Okay, next, negative 2 to negative 1, where does it say we are? Negative 2 to negative 1, this little area, we're in the positive region. So we are not in this region at all. Stay away from this region. So what are we going to graph here? We're by the asymptote, we're going to pick that up. From negative 1 to 3, where does it say we are? In the negative region. So from negative 1 to 3, we're in the negative region. So we want to scratch out this zone right here. So it looks like we're going to pick up this root, pick this one up, and then from 3 to infinity, we are not in the negative region, so I'm going to block out this and go straight. As close as you can, you want to approach that asymptote. So that's what your graph should look like. Does it help to shade these regions? If it does, do it. If it doesn't, then don't do it. Some people it might be confusing. I'm giving you options, how you want to do it. Any better? Yes? Okay, good. Number 2, or number 3 actually, number 3. What's the first thing you're going to do? Factor. When you factor the denominator, it looks like there's some pulling out you can do this. Take an x out. Factor this completely. Sadia. Sure, thanks. It's even your name. Okay, factor completely. Okay, now, is there anything we're going to cross out? means no hole. No, that means there's no hole. Our critical values are at -2, 0, -5, and 1. It's the opposites of these, -2, 0, -5, and at 1. These are the numbers that go in this exclusion chart. At the top, you would put -5, then next is -2, then 0, and then 1. So it looks like it's going to be a fairly larger, even though we've seen larger exclusion charts. So we're getting ready. There's our exclusion chart. So I don't care if you do this next. It doesn't have to be in any specific order. We can do it while we're here. Let's fill this out really quick. So x plus 2. Our zeros at -2. To the left are negative. To the right are positive. 0. Negative, negative, negative. Positive, positive. At -5, we have negative, positive, positive, positive. And at 1, we have negative, 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 and positive. So according to this, we have four negatives, which results in a positive, 3 negatives, 2 is positive, 1 is negative, positive. So this is positive means you're above the x-axis, negative means you're below, between these two regions. Okay, go back to our list of items. Our roots. Where in the numerator are you going to get a 0? Well, at -2, 0. So let's plot -2, 0. Our asymptotes, we have 3 of them. The 3 asymptotes are, vertical asymptotes are x is 0, x is -5, and x is 1. So we need to graph those. So let's graph. How do you graph x is equal to -5? It's a vertical line at -5. 1, 2, 3, 4, 5. At 0. And at 1. Okay? Now this is bottom heavy. So if it's bottom heavy, we have another asymptote. It's a horizontal asymptote at y equals 0. Now we have a 0 here, so that means this asymptote is weak. It's going to have to cross here at some point. Okay, so we don't have a slant, because if you have a horizontal asymptote, you don't have a slant or a parabolic. How do you find your y-intercept? Well, that's when you plug 0 in for x, but guess what this axis is? It's a danger zone, so that means there will be none. There will be no y-intercept for this one, because you have a vertical asymptote. Nothing can hit that line, because if you did, you'd have a 0 in the denominator. Now we're going to put this together. According to our exclusion chart, the region from -infinity to -5 says we're in the red, in the top part. So I'm going to draw that, like that. We're not in this region, so if you want to black this out right here, darken it, shade it to say can't be in this region. From -5 to -2, it says we are in the negative. So it looks like we're coming from this asymptote. We're going to pick up this 0. Even though we have an asymptote here, it's a weak one. This one's a weak one. We can cross it. From -2 to 0, it says we're positive. Now from this little skinny spot right here, it's very narrow. Remember, we have an asymptote here. There's no 0 to pick up, but we want to stay in the negative region. So what you're going to have here is a skinny little parabola. And then from 1 to infinity, we are in the positive region. Does anyone have any questions on that one? 11 points. 2 more. Number 4, factor completely the numerator. X minus 6 in x plus 1 over x plus 1. That's the difference of two perfect squares. Am I going to cross anything out?
Yeah.
That means this normally would be x equals -1 would be an asymptote, vertical asymptote. But instead, since we're removing x equals -1 from this equation, we have a hole where, well, this is our new problem. A lot of you guys are asking me, how do you find the hole? Well, you're crossing out x equals -1 because you're simplifying it. That means you're going to plug -1 in here. So what's -1 minus 6 over -1 minus 1? -7 over -2 is 3.5. So at -1 comma 3.5, you have a hole, which means your graph cannot cross that spot. So at -1, 3.5, you're going to put an open circle. It's a danger zone. It's a hot spot. You're going to skip it. So you are going to be in this area. I don't know where, but we'll find out in a minute. How do you find all the critical values? Well, you're going to use the critical values of your new problem, so 6 and 1. Your roots are where the numerator is equal to 0, so 6, 0. So let's plot 6, 0 before I forget. 1, 2, 3, 4, 5, 6, 0. Our vertical asymptote, that's our root. That's our root. Our vertical asymptote is, the only asymptote we have right now is x equals 1. And the degrees of these are the same, so y equals 1. Where does y equals 1 come from? Where did I pull y equals 1? What's the degree of both of the top and the bottom? They're the same. So you take the leading coefficient, when they're the same, you take the leading coefficients. Whoops, my bad. It's y equals 1. Now I'm going to have to redo it. Redraw it, because I did it in pen. So we have, here's our vertical asymptote, horizontal asymptote. We have a hole at -1, 3.5, and we have a 0 at 6. 1, 2, 3, 4, 5, 6. So that's what we have so far. Our slant asymptote. Do we have a slant asymptote? Because why? Because we had a horizontal one. Okay, y-intercept. Here's our new problem. X minus 6 over x minus 1. To find the y-intercept, you're going to plug 0 in here, and you're going to get 6. So 0, 6. Where is 0, 6? Here's 0, 1, 2, 3, 4, 5, 6. Now, without even doing an exclusion chart, I bet you I can predict that my graph is going to be going like this. That's my guess. It's going to be positive, negative, positive. That's my guess. But the exclusion chart's going to give me more accurate picture for sure. It's going to verify that my prediction's correct or incorrect. So what are your two critical values? It's 6 and 1. So I'm going to put 1 first and then 6. This is a small exclusion chart because we only have 2 factors. So you don't need x minus 6, x minus 1, and f of x. So at positive 6, you have your 0, negative, positive, negative, positive, 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 negative, positive. So my prediction was correct. From negative infinity to 1, we are in the positive region. So this is what your graph's going to look like. It's coming from here. Now, we're not going through this hole. Like, if you were to play a game, Super Mario's, you're jumping over that spot. It's a hot spot. And then from 1 to 6, it's negative. picking this point up, and then this skinny region right here, that's gonna keep us in the positive region from here to here. Does anyone have any questions on that one? Yes.
So one time you go through the horizontal line, if there's a point on it?
If you have a zero, if you have a root, it's gotta pick it up. It's gotta pick up the root, yes.
How do you know that the one on the left isn't a parabola?
How do you know the one on the left, this?
Yeah.
Okay, because, you mean like this, something like this?
Yeah.
Because, that's a good question. See this line right here? That's a horizontal asymptote. And what that is, it's kind of, think of a magnet. If I were to put a magnet next to something that's can be magnetized, what's gonna happen? It's gonna draw closer to it. So that's why. That horizontal asymptote is saying that you're coming from that direction. If you had a vertical asymptote over here, then yeah, it'd probably be some kind of a parabola. But because we have this here directing us, we're coming from this way. We've got this magnet that's making us go to this line right here. That's what gives it the shape. Does that make sense?
Yeah.
Okay. Last one, and we're done. Factor the numerator. What's the thing you're going to take out of the numerator? An x. Let's take that x out. Can we factor that some more?
Yeah.
How? X plus 3, x minus 1, right? Over x plus 2. Does it look like anything is canceling on us here? So what kind of hole do we have? None. What are your 4 critical values? 0, -3, 1, and -2. What are your roots? 0, -3, and 1. Where do these 3 go? Points on the x-axis. So 0, -3, and 1. We have one vertical asymptote. Where is it? This one you don't like because of why? What's the next thing coming? Why does it, I heard parabolic asymptote. Why? Why? Why not these two? Top heavy by 2. The degree of the top is 3, the degree of the bottom is 1. I'm going to let you do synthetic division. Because you can. You can only do synthetic division. And if I do give you a parabolic asymptote for Abby, I will make it just synthetic. This is for Abby. So, help me with the synthetic division. What do I do?
Drop the 1.
Drop down the 1.
Multiply.
What do you do with this?
Multiply
And this is insignificant, don't need it. So what is our parabolic asymptote? How do you interpret this? Y equals 1x squared minus 3. Now, this is an asymptote. It's a fence. If we were to take a wired fence and create a U-shaped figure, where would our fence be? Where is y equals x squared minus 3? Can you graph y equals x squared minus 3? Now remember, it's a broken line. You should all be able to graph. It's 3 units down.
Yeah.
This is your parabola. Actually, I'll do it in red
Yeah.
because it's an asymptote. So at -3, and then you should be able to plot this parabola. I gave you an easy one. I didn't give you one with, you know, a crazy axis of symmetry and you had to find the zeros and all that. I just gave you 3 units down, over 1, up 1, over 2, up 1, 2, 3, 4, and over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be good enough. So what is it? It's this right here. It's broken. It's a fence. How do you find the y-intercept? You plug 0 and you get, guess what? 0, which we already have it, or we already have it grabbed. Now, exclusion chart, help me out. What are my critical values once again? Okay. So what do we have here? Let's fill this out. Where's our 0 here? Which one of these? Here's our 0, to the left, negative, to the right, positive. -3, negative, positive, 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 positive. At 1, negative, 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 positive. At -2, and now we count. 4 means we're positive. 3 is negative. Positive, negative, positive. So from negative infinity to -3, where are we? We're in the positive region. So up to here, you don't want to be in this region down here. Up to this spot. So you're going to stay away. So what could we draw? That's from here to here, that's positive. Should you go in this region, knowing that you have to pick this up? No, I would go in this region right here. So you're gonna go from here, come down here. Now according to this, we have, oh, okay, thank you. From -3 to -2, this little skinny area, you're in the negative. So you're gonna go down here. From -2 to 0, we're in the positive. So I'm gonna follow this asymptote. From here, from 0 to 1, it says we're in the negative, so skip down right there a little bit. And then from 1 to infinity, we're in the positive. Should I cross this asymptote? No, I'm gonna just follow it along. Does that make sense?
Yes.
Do you feel better about this? Now your test, individual test is Monday. When you come in Monday, what assignment are you gonna have ready to go with your name on it and completely filled out? It was a 3-day assignment. That packet, I don't wanna hear, it's at home, it's in my locker, can I bring it in later? It's due, I gave you plenty of time to work on it in class. Thank you.